Good afternoon, everyone. Welcome back to the second session of day 4 on understanding image forgery. So just let us recall the things what we have discussed in the previous session, that was on credibility of images on social media. So we have discussed few points like this. We have understood there is no single specific standard procedure for evaluating authenticity or integrity of the image. So there is no yes or no answer, or there is no standard method is available. One thing, and just by visual inspection, it is not possible to differentiate original image from the forged image. So hence we have understood that it needs some expertise, and we need to understand some features like non-image features and image related features to analyze the images. So we have understood about non-image related features in the last session. So in this session we will understand how these image related features can be used for detecting image forgery. So in this session, let us understand how image forgery will be done, as well as how to detect such image forgery. So as an introduction, I'll just give the definition of image forgery. Image forgery or image tampering means manipulation of the digital image to conceal some meaningful or useful information of the image. So image forgery is also called as image doctoring and photo montaging and image splicing, superimposition of the photo or compositing photos. So all these are synonyms of image forgery or image tampering. So yeah, this is due to the availability of sophisticated user-friendly image editing software tools which enables easy alteration of digital images. So as Albert Einstein said, technological progress is like an axe in the hands of a pathological criminal. It is very true in this case of digital image technology, because it has both constructive purposes and as well as destructive purposes. So it has a lot of advantages and a lot of usefulness for medical field, education field, and entertainment field. At the same time, that it has lost its truth. I mean, it has lost its truthfulness of the images, and it is also using for destructive purpose like defamation or cyberbullying or etc. So we have seen all this in our previous session. So I could say this is something like plastic. So plastic is a lot of usefulness, and at the same time it is harmful to our environment as well as for our on our health. So this is all about digital image technology. As I shown before, and we could not identify which is original or which is fake among these. So just I am showing again, just to recall that just by visual inspection, it is not possible to differentiate original image from the fake image. And this leads to the unauthorized distribution and misuse of the data without license, without having a consent of the owner of the photo. It keeps on distributing without their permission, and hence we need to authenticate such images, as well as we need to validate their content, and if some misuse happens, we need to detect such forgeries. So these are the three main concerns, and we will discuss on these three points in this session. So we have to authenticate the image, and that means who has created and copyright information of the images, and validate the content. So content must be protected against the manipulation, and if at all it is manipulated, we should have some way to detect such forgeries. So let us see all this in this session. There is no single standard method or procedure for evaluating authenticity and integrity of the images. So it can we can find out a probabilistic answer for this. It is very difficult to find a deterministic answer like yes or no. Yes, it is fake image, it is original image. It is highly difficult. And as we know, the technology that allows for manipulating images as far outpaced the technological development of methods for detecting fake forgeries. That means the image processing tools are more advanced, are more effective than the image forgery detection techniques. So actually forgery detection techniques are lagging behind when compared to image processing techniques. So hence experts also agreed that just by visual inspection, it is distinguishing authentic image from the forgery image is difficult. So let us understand how many ways an image can be forged. So how many operations will it may be used to create a forgery. So once I am listing few operations here. One operation may not be possible to create a convincing forgery or the realistic forgery. It is usually a combination of these operations to create a realistic forgery. So one such operation is compression. So compression is usually used to save memory space, and it helps to transmit the image quickly. But the other phase, it mitigates the investigation process. That means it eliminates or it erases the evidences of the forgery in their image. So you can see this, the quality of the image, high quality of the image, it takes 77.9 kb, and other image is of just 19.11 kb. Visually we cannot differentiate, and we cannot say which is better one or which is poor one. So anyway, this resaving operation again and again, that recompression operation made that this investigation process, it is very difficult to get the clues of such forgeries. And enhancing is another operation which is used to improve the quality of the image or visibility of the image. So using this operation, it is possible to convert a day image into night image or night image into day image. Like this, the operations may be used for with bad intention. And recoloring is we can change any color to any other color. So this also one kind of manipulation, but it is very difficult to detect such manipulations, because it will not alter or it will not leave any such clues on the image. And retouching is another operation, which is, you can see that this is used to create a beautiful photo like this. This is a local image alteration. So local region of the image will be manipulated to create a convincing forgery. And by using this retouching tools, this kind of images, by lightening the skin tone of the celebrities, and it is published on magazine cover, something like this. So retouching tool is misused in this manner. And panorama is helpful in taking photograph of an elongated field of view, which is usually created by joining multiple photos which has overlapped field of view. it is very helpful to view elongated field of view, but this is also one operation. It could be used for manipulation. And in painting is another operation which is used to reconstruct the destroyed portion of the image. So if some painting is destroyed, some portion is like this, so this can be in painting operation can be used to reconstruct such portion to create a quality image. Such in painting operation is also misused in this way to remove the object from the image. So here the similar portion will be copied and pasted to conceal a portion object of the image. And another such operation is morphing. By this morphing, an non-existent face can also be created. See, the left photo and the right photo are two different faces. The middle photo has been created by combining the features of both the photos, both the faces. So you can see the middle person is not existed. So, but it is possible to create a non-existing person also like this, just by combining the features of the two or more faces. And copy paste is another form of manipulation, that is copy and pasting some other portion of the image and on some other another image. Here two or more images are used to create a new image. You can see that this is a magazine cover where they have created a copy paste forgery just by adding an African father here. They have removed the real father, who it is a Canadian family. Here they have added another a person who is African, just to show that the multinational family, the magazine cover. So like this. And another photo, it is you can see here the right photo and the middle photo are the real photos. The left photo was created photo. The Osama bin Laden who has died by US people military, and this left photo, that is a composite photo, was published in Pakistan before his death itself. So in most of the newspapers and TV channels, they showed like, or they transmitted like it is Osama bin Laden has been killed by US military, like that. So like this, it creates a unrealistic story. And copy move forgery is another operation where it is nothing but a cloning operation, where you can see this, the left photo is original and the right photo is forged one. Here the number of swans are replicated. I mean, it is copied and pasted on the same image, another object on the same image. So these are all the operations which are used to create forgery. And as I said, this is not a single operation is used for creation of a forgery. Maybe a combination of these operations are used to create a convincing forgery. Let us understand how to detect such manipulations. So we have understood there are so many ways to create a forgery. Then how to detect such forgeries? The first and foremost method is studying the properties of the image. As we know that the image metadata will be stored maybe inside the image, or maybe as another file attached with the image. So that is called EXIF metadata. EXIF in the sense exchanged image file format. This metadata includes date, time, camera settings, and other possible copyright information. This metadata is usually editable, and this can be extracted by many tools. And it is also possible to just by on clicking a right button on the image, we can see the properties of the image. But there are other tools also available to extract such information. And there are three difference in this. That is, one is few cameras will give a large number of metadata, and a few cameras will store only less number of metadata. So that varies from camera to camera. And another important point is this metadata is editable. We can change the date of the camera, date of the image has been taken, and in a camera model or camera name or anything, all the fields are editable, so it is possible to change or edit the information. And sometimes when we upload our photos to any social media or any websites, sometimes we delete this, they erase all the metadata before uploading. Once we upload, it automatically erases all the metadata of that image. So hence we cannot rely on this information to decide the original image or the fake image. So just it may give a hint of for a detection process, but we cannot completely rely on this metadata information to decide the credibility of the image. Let us see the image authentication. Image authentication is a process of preserving image identity and its content. Now, there are two techniques to preserve this content or the identity of the image. That is watermarking and digital signature. Watermarking is nothing but embedding some information or hiding some information into the image. It may be a text or a pattern, but this information must be added at the time of recording itself or immediately after the recording. This information is typically used to identify ownership of the copyright of the image. It is also used to protect digital information against illegal possession and manipulation and usage and distribution. So it is very useful, but it has advantage that it has a disadvantage that some extra process need to be done on the original image. And it is also possible to it is also possible to do with the camera itself, but some camera, but all the cameras are not equipped with this facility. Hence the cameras or the images which are available in our market, they are not come with this watermarking. And there are two types of watermarking. One is visible watermark and invisible watermark. And next one is digital signature. Digital signature is an authentication mechanism that enables the creator of the information to attach a code that acts as a signature. Some code, hash code, usually hash code will be generated from the image by using some hash function or hashing technique, and that hash code will be encrypted by private key of the owner, and that encrypted code will be attached with the image to authenticate that image. So to digitally sign a message, the sender would generate this hash code, and that hash code will act as a digital signature when it is encrypted by his private key. So that signature also helps us to detect the forgery, because when a single pixel of an image gets changed, the whole hash code will get changed. So you can see here the first digit 9 has been changed to 6 in the right image, in the modified image. You can observe the hash codes. The complete hash code has been changed. So even if you change a single pixel also, it changes the whole hash code. So like this, we can authenticate those images. This also helps in identifying the forgeries also. But the disadvantages of these two techniques are it has to be embedded, or it has to be done at the time of recording or immediately after the recording. And both are possible only if we need some extra facility must be needed. That is, camera must be equipped with this facility, or some software must be used for this purpose. So hence, we need some technique which works in the absence of digital signature or watermarking. So understanding image forgery in the absence of watermark or signature is very important. Now let us try to analyze image related features to verify its authenticity and integrity in the next slides. So this approach is called passive technique. In this passive technique, the assumption is that although digital forgeries may leave no visual clues that indicate forgery, but they may alter the underlying statistics of an image. So definitely when a forgery is done, so definitely it leaves some clue. It may not be visible, it may visually we may not able to identify it, but definitely it alters the natural statistics of the image. So on that assumption, these passive techniques are invented, and it is proposed. Those techniques are categorized in as four groups, that is pixel based techniques and camera based methods, or physical based methods, and format based methods. So let us understand and let us discuss each of these methods and their examples. So pixel based methods usually detects the anomaly at the pixel level correlation, and camera based methods tries to extract the features of the camera which will be introduced by the camera on the image. And physical based features are something like the interaction between the image and the interaction between the camera and the light and the object. So the anomaly introduced between these three objects will be studied under this physical based techniques. And format based techniques which exploits the pixel level correlations introduced by specific recompression technique. So this pixel based features are used to analyze pixel level correlations that arises from a specific form of tampering. Such tampering are duplicate region detection and resampling detection. Duplicate regions we have seen. This is one example of such duplicate region forgery. That is, a person is lying on the grass, so the other portion of the grass has been used to conceal that person or the object. And the down photo, which is here, the object is duplicated again to increase the number of swans. So the cloning is one such operation where the portions are copied and pasted over the same image. If it is done carefully, it is very difficult to detect such cloning operations visually. Hence, any copy move forgery introduces a correlation between the original image segment and the pasted image, pasted one. That means we can understand that when we look at this, so we can find out the features which are pasted over on other portion. Definitely, those two portions will exhibit the same properties. So that idea is used here to detect this forgery. That is, first we will divide the whole image into fixed size smaller blocks, and each block will be used to extract the features, and it will be used to represent as a small number of transform coefficients, and such transformed coefficients will be sorted lexicographically, and then in the sorted list, definitely the matched blocks will be placed in the adjacent positions. So hence the segments may not match even exactly, but only approximately, because even though they are same portions exist on the same image twice or thrice, but they may not exactly what exhibits the same exact values or coefficients, because retouching operations or some transformation will be done on those, or recompression also possible to be done by resaving that. Hence such operation, such values may not match exactly, but approximately it will match. So anyway, this technique has been done by using DCT and PCA and SIFT methods. The DCT is used, that is discrete cosine transformation, is used in this forgery. So you can see that truck has been covered with the green portion of the same image. When we apply this discrete cosine transformation, so we can identify such similar blocks, because the same greenery has been already exist on other part of the image. Hence those two exhibits the same features. So that can be identified by this method. And PCA is another technique which is used for dimensionality reduction. So this is also exhibits a very good property to express in a small number of coefficients of each block. So PCA also gives a very good result even when the compression levels are increased or decreased. It is also working at the condition of different compression levels. See, for example, if the JPEG image is saved at 50% quality or 60% quality, even at the 100% of quality, so this method works efficiently and accurately. It identifies the cloning operation. And another feature, that is SIFT features, which is usually used to describe the local region of the image. So it is represented as a key points. So here the lines you can see that matches the key points, where if the two key points matches, and then there will be a line drawn between those two key points. So this also accurately identifies a cloning operation or copy move forgery. So that elephant portion has been concealed, or it is removed and pasted by other portion of the greenery. So that is you can see the matching between the pasted portion and the copied portion here. So this is how the cloning operation or the duplicate regions can be identified. And another major form of forgery is image splicing. And this is a common form of photographic manipulation. Here, two or more images are used. So in the previous forgery, only a single image is used to create the cloning operation. I mean, cloning operation is being used to create a forgery. I mean, single image has been used in a copy move forgery, but in image splicing, usually two or more images are used to create a new image. So in this case, it is always necessary to resize or rotate or stretch a portion of an image to match with the host image. So the object size must be matched when we create a new image. So in that case, it is always necessary to resize the portion of the image, I mean copied portion of the image. So resampling introduces, this operation is called resampling. This resampling introduces specific periodic correlations between neighboring pixels. And such specific form of the correlations can be easily determined by using interpolation technique. So as we have seen the first graph, it is the original pixel values. When we resize it, the original pixels will be elongated and the intermediate value will be identified by interpolation method. So that interpolation operations creates a pixel, some kind of specific kind of pixel correlations. So because this intermediate pixels will be generated by taking average of the neighboring pixels. Hence, all these exhibits a periodic correlation. So that can be identified by finding the differences in horizontal direction. Second order differences will give this kind of result. Maybe if we find out horizontally or vertically, so that finds when we take the difference between the pixels of alternative pixels or consecutive pixels, it gives us a 0 as a value after 2 or 3 times when we do this operation. So this exhibits the this kind of detection of the forgery. And another method is used to detect resampling operation is wavelets decomposition. So this also indicates the forgery, but there are some disadvantages or drawbacks with this. So this may not work if the portion of the image is not been resized. So if the object size matched exactly, then there is no need of resizing. So if we don't do that resampling operation, then we cannot detect such forgery by using these methods. So then the camera based features, how to extract these camera based features are, we have to understand how camera works. So each component of the camera introduces its own characteristics into the output image. Such characteristics can be identified as an evidence for the determination of source camera. So the inconsistencies in can be used as evidence of tampering. So as we know, the image which will be taken from each camera is different from the image which is taken from other camera. So camera characteristics will be automatically inherent to the images. So such camera characteristics will be extracted from the image, and it will be used as a evidence for image forgery or to find out the image, camera, source camera. So before analyzing or before understanding camera features, let us understand what are all the components involved in the camera to form in the formation of the image. So light from the scene, it falls on the lenses first. So the light from the lenses, it passes through few optical filters, say anti-aliasing filter or infrared filter. Excuse me. And then it falls on sensor, that is a color filter array, which senses the color of the light, and this converts the photons into electrons, and this electric charge will be converted into voltage. So that voltage is called as a pixel value. That voltage will be converted as a pixel value. So that means photons or the light will convert to electrons. Then electrons, electric charge will be converted into pixel value. So that pixel value contains all the color related information. If the camera is set to raw image mode, then that image will be saved as a raw image, that is called digitally or digital negative. So that sensor sensor image is a single array. So later that will be converted into RGB or any other color space that will be interpolated by using a CFA interpolation technique, and it is converted into 3 color spaces like RGB, RYV, or any other color spaces. So, and then the post processing operations will be done on this RGB color space, like gamma correction, etc. So later, compression, etc. So later, the compressed image we will get from the camera. So hence, in this process, we can see that lenses and the sensors and the CFA interpolation techniques, all these are built in the camera, and this introduces its own characteristics into the image. So these components are the characteristics of such components can be extracted from the image to relate with the source camera. So lens aberrations and sensor pattern noise were used as features in image tampering or source camera identification. That lenses aberrations introduced because lenses are not perfect. Lot of imperfections like lens radial distortion, etc., will be added to the output image. And sensor pattern noise, sensors are also not perfect, so this has some inbuilt imperfections. When we take a dark image, even though it is clicked at the dark light, so it gives some values at the sensor, so that means it has some imperfections. So that imperfections is different from each camera, so such imperfections are studied and correlated with the camera. So when we I'll just explain one by one. The lens radial distortion is nothing but it is deviates from the rectilinear property. That means straight lines are not straight in the images. You can see that this property may be exploited to detect the forgery, because two portions of the image, if it does not exhibits the same lens property, then it is we can decide that that image has been created by adding two or more images. So like that, this lens radial distortion has been used for image tampering. Lens radial distortion parameter, that is K1, is shown here. So a checker box, that is a computer generated image. So it, when we extract the straight lines of this checker box, it is exactly straight. So hence if you find out the distortion parameter, that value will be always 0. So if it is having any deviation from this rectilinear property, so this gets some value, some other value, maybe negative value or the positive value. So similarly, each camera exhibits different lens radial distortion property. This has been taken from a Sony camera at different zoom levels. So you can see that the different zoom levels exhibits the different rectilinear property. Those lines are not straight always. So this property is different from different cameras. So you can see that there are 6 cameras has been taken, and we have considered the same company camera with different models. So two Sony cameras are there, not 3 Sony cameras are there. So all are different models. So all these, even though the manufacturer are the same, but they exhibit the different property, even their model is different. So this property, you can see each camera has its unique nature. So this property is being studied like this. When we copy and pasted two portions of different images, that can be identified by studying this lens radial distortion. So here the lens radial parameter, that is K1, will exhibit different values for the different straight lines. But there is a drawback in this technique, that if we need the straight lines in this images. Without having, if we don't have a straight lines, then we cannot study this specific kind of property. So this is a drawback. Of course, all the photos does not have a straight lines, hence this technique will not work for that. And photo response non-uniformity noise is a property of the sensor. So this sensor has a unique property. Each camera each sensor has which exhibits different PRNU noise. So this acts as a fingerprint of such of that sensor, that PRNU analysis is most often used in an attempt to find the source of a digital camera. So it is very useful to relate with the, or correlate with the source camera. It is very much useful to identify which is the source camera of the given image, and it is also used to identify the tampering portions, because if the two portions of the same image exhibits different PRNU noise, then it indicates that those images are those portions are from different camera. Usually this PRNU is not possible to extract from a single image. We need minimum 50 images to extract PRNU noise. So to analyze this PRNU noise, we need minimum 50 images, and those images must be taken on the gray wall or a plain scene. And so then only it is possible to analyze the PRNU of the camera. This is the limitation again. So if we have studied the PRNU of the particular camera, then only it is possible to correlate with the other image. I mean, correlate that portion to the camera. If we don't have that camera, and if we don't have studied the PRNU pattern of the camera, then it is not possible to detect such forgeries if it is used in tampering operation. So like this, each method is having its own drawbacks. Hence, we cannot propose a single technique for detection of forgery image from the fake image. We need to apply specific technique to detect specific kind of forgery, and this is the result of that PRNU noise extraction. You can see that this images, I mean, it is the PRNU noise is extracted from each portion of the image, smaller portion of the image. If it exhibits the different PRNU noise pattern, then it is considered as a tampered image. So this has been given a good result, but it is done with the prior analysis of the PRNU noise of the specific camera. And another technique is physical based features. This technique detects anomalies in the three-dimensional interaction between physical objects, light, and the camera. When image is created by splicing together individual images where it is very difficult to exactly match the lighting effects on different objects. Now, for example, the amount of light striking a surface is always proportional to the surface normal and the direction to the light. So that means the lighting inconsistencies can be studied over the image to for tampering detection. If the lighting conditions are different on the different objects on the same image, so that gives a hint of tampering. With the knowledge of 3D surface normals, the direction to the light source can be estimated. So this method is based on the intensity gradients on the surface of an object. So this is usually determined by computing intensity gradients on the surface. So the gradient distribution can exhibit light sources in the image. So by computing this intensity gradients, we can find out the direction of the light. So if image having different lighting conditions, then it may be a hint of tampering operation. For example, here I have shown this Sachin, I mean this photo earlier in my previous session. You can see the lighting conditions here. So the sunlight falls on the objects in the same direction, but on the Sachin face, it is the direction of the light is different. Like this, the lighting conditions can also be studied for an evidence of tampering. But this fails when multiple light sources are there, and if it is taken at indoor, so indoor photos also exhibits different lighting conditions or different multiple lighting conditions. So in that case, it may fail. Anyway, sometimes it is possible to study this kind of evidences for tampering detection. This has been done here, and it gives a good result if at all, if it has a single source of the light. So if it has multiple sources or lighting conditions, sometimes it is not possible to detect, then it may fail to detect such forgeries. So another method is format based features. Since JPEG is the most widely used image format, technique that detects tampering deals with JPEG lossy compression scheme, is which exploits the specific properties of this compression technique. So this has been used for forensic analysis, and to understand that recompression technique, so that creates that exhibits a specific type of correlation of recompression technique. So before understanding that, let us understand how this JPEG compression works. What is the basic steps involved in that? So first step is it uses a discrete cosine transform. So before that, the image will be divided into 8x8 blocks, and the first the whole image will be converted into luminance and chrominance space, and hence the image, the matrix of the luminance space will be divided into 8x8 blocks, and then it will be converted into a frequency space by using this DCT, and then a quantization step will be applied. That is, the DCT coefficients are divided by a quantization table and rounded to the nearest integer. Especially this step is a lossy step. That means we lose the information here. That's how the JPEG compression reduces the size of the memory. So there are 100 such quantization tables are there, which decides the quality factor of the image. So based on the quantization table which is used in each device, so we get the image quality. And the last step is lossless entropy coding of quantization DCT coefficients by using Huffman coding. This method is lossless step actually. So the major property we need to study here is quantization table. So as I told you, there are 100 quantization tables are there. This is shown with the graphical representation of the JPEG process. So like this, there are 100 quantization tables are there. So each camera adopts different quantization tables. So as I said, this quantization table decides the quality factor of the image. So camera chooses this quantization table based on to balance between the memory space and the quality of the image. So if we use the quantization table 1, it may be a it may take more memory to store that image. That means it may be a lossless compression. If we use the 100th quantization table, it will be a lossy compression table. So that may take very less memory to store the image. So this is 8x8, and there are three matrices are there. Each one of its size is 8 cross 8. So it will be applied on each three different color spaces to decide the quality of the image. An image is tampered implies that it must contain two parts. So that means tampered image contains untampered part and the tampered part. That means if we copy and pasted a new portion on the image, so that the pasted portion will be tampered part, and other rest of the portions are untampered part. So in that case, this quantization table is used to extract from that image and used to study the uniqueness of this quantization table. So in the majority of cases, cameras from the same manufacturer and they share the same quantization table. So by extracting the quantization table from each image, so it indicates that from which camera it has been produced. If it is pasted portion is there, so then it exhibits the blocking artifacts like this. The division of 8 cross 8 blocks will not match exactly. So it gives some kind of evidence when we do this kind of operation. Hence, such property can be extracted for identification of tampering portions. For that, ELA is used. So ELA is error level analysis. Error level analysis highlights the differences in the JPEG compression rate. So if it is the tampering is being done by compositing two or more images, and those images are from different camera, even on the same camera image also, that exhibits a different compression rate if it is tampered. So hence ELA helps to identify areas within an image that are at different compression levels. With JPEG images, the entire picture should be at roughly the same level due to the introduction of an homogeneous amount of errors across the entire image. The error what produced by this recompression technique of this JPEG format, this must be homogeneous throughout the image. But when it differs in each portion, that can be analyzed as a tampering portion. So this algorithm calculates the average differences of the quantization tables of each blocks of pixels across the image. So when it exhibits different properties, then it indicates the tampering operation. So this is one such example. You can see that this is the that portion has been copied and pasted over here. So this result shows that all except that floppy disk portion, all other portion exhibits the same error level. So like this, we can analyze this tampering operation, but this may also fail sometime when, because it produces based on the contrast of the images. So when the contrast difference is there, so error level also differs. So each method has its own drawback. And so you can see this original image and the altered image. The ELA is it clearly shows the pasted portion here. But as we have seen a lot many methods now, that is pixel based techniques and camera based techniques and physical based techniques and format based techniques, all these methods will work at specific conditions. So for all the kinds of forgeries, there is no single method to detect. So hence we need to apply all these methods to detect the forgery. If it has a different if it may give an inaccurate result when the specific detection procedure will not work. That means each kind of forgery needs its specific detection procedure. So hence it is a unfortunate that there is no standard method to detect all kinds of forgery. So who are the audience here, they can work on this to and what to propose new techniques which can work in all the conditions. So as we have already seen that we need specific methods to detect specific kind of forgeries, because image manipulation techniques are more extreme, are far extreme than the technological development of methods for detecting fake forgery. So these techniques detection methods are far behind when compared to the manipulations done on the images. So image processing techniques are far outpaced when compared to the detection techniques. Hence it is needed to use multiple detection methods to evaluate the credibility of an image. But we don't leave the hope that as Locard's principle says, all the forensic experts works on this principle, that is every contact by a criminal leaves different behind a trace. So every contact of a criminal leaves some trace. So we have to identify such clues. So without leaving a clue, one cannot do any kind of crime or any kind of operation. So it definitely it leaves some traces or clues. We need to detect such. So this may be true in case of physical crimes, but in case of digital crimes, it is very difficult to identify or to trace such clues, because in digital data is volatile, and it is highly possible to create a forgery without leaving a clue. And what we can conclude is, it is sometimes it is possible to say an image is original image or the forged image, but the challenge is here what portion has been manipulated. So this is the main challenge is here. So just by looking at the metadata information or any other authentication process, it is possible to say that it is a original image or the forged image as a whole. As a whole, we can directly say that it is the direct image from the camera, or it is resaved, or it is recompressed image. But localization of a particular portion of the tampered portion of the image is a main challenge here. So this is what we are the forensic experts are facing, the localization problem. That means identify a particular portion which has got manipulated, or what operations has been done on particular portion of the image. So that exactly identifying such manipulations is very difficult. So as a whole, it is possible to say it is a forged image or a original image if it has all the properties in the metadata, or if it intactly it is having the natural statistics of the image, then it is possible to say original image. If it single property has been differentiated, then we can decide that it is a forged image. But how it is forged, what manipulation operations has been done, so that is a challenge now. So what has been done on the what exact portion has been changed, or what operations has been done, whether it is retouched operation or inpainting operation, or it is just done the recompression, or it is copy paste forgery, or it is a copy move forgery. So identifying such exact tampering operation is a challenge now. So by leaving this question, I am requesting you that you can in the next session you can bring a few photos for doubtful photos if you have, and let us apply all these methods to analyze the image, and otherwise also I'll show you how to detect such forgeries. At least probably let us try to find out what the image tampering has been done or not. So in the next session I'll show you how to analyze image related features by using the detection tools. Anyway, non-image related features can be analyzed as I have explained in the previous session. So let us analyze the image related features in the next session. If you have any such images or the photos or doubtful photos, you just mail to me and I'll try to detect whether it is a original image or a forged image in the next session. So I'll use all these methods to detect a forgery in the lab session. So if anybody have any questions, you can ask. I think no questions.